Okay, so now we're going to look at some complex analysis. So we're going to do this integral here. So the integral of the conjugate of z with respect to z, and the integration parameters is the gamma. So this gamma here, we've noted here, is where z is the modulus of z equals 2. So first of all, we need to look at what the parameters of integration are. So if we draw that here on the Cartesian coordinates, the Cartesian graph. So if z is always 2, basically what we've got is, we've got a unit circle with radius 2. So I could just draw this here, that would be 2, that would be minus 2, minus 2i, and then plus 2i. So the next stage to do this integral, we need to go from the z world and into the t world. So we take a parametrization of this. So when we take a parametrization of a unit circle, we go in an anti-clockwise manner. And the distance from here to here, and here to here, here all the way around, the radius is 2, so that's 2. And then what we do is we use the exponential function, e to the it, so that will give us all these here. And then what we say is that t is in the set from 0 to 2 pi. So that will give us that direction there, anti-clockwise. If we want to go clockwise, we go from 2 pi to 0, then we have to put a negative in here. So that would be negative 2e to the it. Okay, so now what we do is now we call this gamma of t. So that's what we have here now. So now what we now need to do is to go into the t world, to take the dz to the dt, we need to take the derivative of this. So the derivative of gamma, the lowercase gamma, is the derivative of this. So now we would get 2, and then we take the I, which is the constant multiple, 2ie, and then the it stays. So that's what we have now. So now we can rewrite this integral now. Let's write it here. So what we can say now, in the t world, gamma goes from 0 to 2 pi. So 0 to 2 pi. And then for dt, we write 2i e to the it. And then what we do is we take the conjugate of the original. So 2e to the it becomes 2e to the minus it. So I write that here as 2e to the it and then dt. Okay, so when we take the conjugate of any complex number, the real number stays the same, and the imaginary number, that becomes, we flip the sign. So here we'd have a positive, so that becomes a negative. So basically it's just flipping it and in the reflection of the real axis. So now what we do is we can just change this here now. So that would lead us on to 2e to the it would then become 2e to the minus it. So now we have 2i e to the it times minus 2 e to the it. Okay, sorry, that stays positive. We put the minus in here and then dt. And again, not forgetting parameters of integration, 0 to 2 pi. Okay, now we need to work out what this is. So we can multiply this up. So we've got 2i times 2, that's going to give us 4i. So again, 0 to 2 pi. So the 4i is constant multiple, so that can come out front. E to the it times e to the minus it, that's just going to give us 1. And then dt. Okay, so now we're ready to integrate. So 4i, constant multiple will stay. And then what we do is the integral of 1 in the t world is just t. So let's just write that down as this for now, and then t goes from 0 to 2 pi. Okay, moving on. So let's work this out. So when t is 2 pi, we've got 4i times 2 pi, and then when t is 0, we just subtract 4i times 0. Okay, so now we can simplify this up. This will disappear, and then we just multiply this up, so that will give us 8 pi I. That is our answer.